2.6 Combinations of Functions, Composite Functions. Find the domain of the function. These look complicated, the function notation, but it's really not that bad. So we want to find the domain of the function. Okay, so domain of the function. So we're looking for limitations on the domain, or what are all the possible x values that we can plug in. Now, as we see right here, we don't see any x's in the denominator, and we don't see any x underneath any even. So we're looking for this, or we're looking for this, basically, something like that. And we don't see either of those in the first one. So we would say the domain on this one is negative infinity to infinity. That's the domain. There really aren't any limitations on that one. We look at the next one. Do we see any variables in the denominator? Yes, we do. Okay, fair enough. So what we have in this situation is we know that we don't want the denominator to be equal to 0. Okay, so what would make the denominator equal to 0? Well, it looks like if x is equal to 11, it makes it equal to 0. Therefore, x cannot be equal to 11, right? 11 minus 11 is 0, and 7 divided by 0 is undefined. So we cannot have x equal to 11. So we want to include all numbers but 11. So it's negative infinity to 11, union symbol, 11, all the way up to positive infinity. So that little 11 next to the parentheses and that union symbol between means we're including everything but the 11. That's not included because of the parentheses. If brackets include, parentheses exclude. Okay, let's try the next one. So in this case, do we have any variables in the denominator? Yes, we do. What do? We set it equal to 0. Okay, what we have here is a quadratic. Now we can see whether or not we can solve this using the zero factor property by factoring, which is I'm going to try first. So first step in solving a quadratic using the zero factor property is to set it equal to 0. Check. Then we factor it. Next step is to factor. So square root of x squared is x. It ends in a positive, which means the signs are going to match. Middle term is a negative, which means they're both going to be negative. I'm looking for two numbers that you can multiply together to give you a 22. That if you add together would give you a negative 13, and they're both going to be negative. So negative 1 multiplied by negative 22 gives me a positive 22. And if I add those together, negative 1 plus negative 22 gives me negative 23. That obviously is not going to work. How about a negative 2 multiplied by a negative 11 gives me positive 22, which is what I want. And negative 2 plus, negative 11, sorry. Let me erase that and do better. There we go. Negative 2 plus negative 11 gives me negative 13. And sure enough, that works. So we know this is the combination, negative 2 and negative 11. Two numbers that we can multiply together to get the 11 that if we add together would get you the negative 13. So negative 2, negative 11. Okay, third step is we set the factors equal to 0. So we have x minus 11 equals 0, plus 11, cancel, cancel, x is equal to 11. Okay, so what we know is that basically, and this is the weird thing again, because 2 and 11 would make it equal to 0 in the denominator, we know that x cannot be equal to 2 and x cannot be equal to 11. So we have negative infinity all the way up to 2, union 2 all the way up to 11, and then union 11 all the way up to positive infinity. And that's how you write it in interval notation. So we exclude the 2 here and here. We exclude the 11 here and here because we're using parentheses. Again, parentheses exclude where brackets include. So we use that. Okay, on this one right here, do we have any variables in the denominator? The answer to this one is yes. So we have an x minus 6. And what would make that equal to 0? Well, 6. 6 minus 6 is equal to 0. So x cannot be equal to 6. What about x plus 9? Equal to 0, minus 9, cancel, cancel. Well, x cannot be equal to negative 9 because negative 9 plus 9 is 0. So how do we do this when we go negative infinity all the way up to negative 9 union, and then we'd say negative 9 to 6, and then we'd use the parenthesis union, then we do 6 to positive infinity. So we have a hole, right? So we have a hole over where the 9 is, right there, and right there is a hole. And over in this case right here, we have a hole here And we have all here. Now, because interval notation must be in smaller numbers must be on the left, larger numbers must be on the right, you do need to put the -9 over here on the left and then the +6 further to the right in this case. So be careful about that. We look at the next problem. The next problem does actually have a limitation, but it does not have variables in the denominators. This one has variables underneath a square root. So what we know about that is that x plus 7 must be greater than or equal to 0, right? So how do we figure that out? We subtract 7 from each side. We have x is greater than or equal to -7, okay? So if I plug a -7 in there, -7 plus 7 is 0, square root is 0, 0. That works out perfectly okay. But it can't be less than that. It has to be greater than that. Okay, so how do we write this in interval notation? We can include the -7, and it goes all the way up to positive infinity. So that's your domain. The next one is done basically the same way. This is a square root of 8 minus 2x, whatever that is. We do know that 8 minus 2x is greater than or equal to 0. So -8, whoops, cancel, cancel. -2x is greater than or equal to 0. Divide by -2, divide by -2, cancel, cancel. And we would say x is, but since we divide both sides by a negative, we flip it, less than or equal to 0. And if x is less than or equal to 0, let me erase that. Write that correctly. Okay, so double check this, greater than, then we flip it, less than. Okay, so the way we would write that is we'd have a 0, that's where we're starting, but since x is less than or equal to, we're going to go to -infinity, and that is your domain in that one. Okay, hopefully that works. So for the first find f plus g, f minus g, fg, and f divided by g, then determine the domain for each function. Okay, so all this is really saying is we're going to take two functions, and first we're going to add them together, then we're going to subtract one from the other, then we're going to multiply them together, and then we're going to divide one by the other. Okay, first one is f plus g. Okay, so let's do substitution. So we have f plus g. What is f? So that's basically shorthand for f of x, right? We're saying plus g of x. Okay, well, what is f of x? Well, f of x is 5x minus 7 plus, and what is g of x? That's x minus 4. Okay, so now we say 5x plus x, or plus 1x. 5 plus 1 is 6x. We say -7 plus -4 is -11, and we got it. So that's f plus g. Okay, well, what about f minus g? Okay, well, that's the same as f of x minus g of x. What is f of x? That's 5x minus 7 minus x minus 4. So now we're saying 5x minus 1x, which would give me 4x. -7 minus 4, which is the same as -7 plus 4, which would give me a minus 3. And that would give me f minus g. Next we have fg, which is the same as f of x times g of x. And what is f of x? F of x is 5x minus 7. And what is g of x? X minus 4. So we FOIL these together. F of x times, 5x times x is 5x squared. Then 5x times -4 is -20x. Then -7 times x is -7x. Then -7 times -4 is +28. Then we say 5x squared minus 20 minus 7x is minus 27x plus 28. And that's it. Next, we want to divide. So they're saying f over g. That's really the same as saying f of x over g of x. And what does that mean? Well, what that means is we have 5x minus 7 over x minus 4. And that was not going to simplify easily or nicely, so we're just going to leave it like that. So that seems like that would be the quotient, the result of division there. Okay, so hopefully that makes sense what the new notation means. It's just telling you you're going to add, subtract, multiply, or divide two different functions, and that's it. Okay, now let's try composite function. Composite's a little more complicated, but not too much. Here we're saying for f of x is equal to 4x and g of x is equal to x plus 7, find the following functions. So we're saying f composite g of x. This is there's a couple of ways of looking at this. You're kind of backwards plugging things in. But another way of kind of looking at it is this is f, but instead of f of x, it's g of x. That's kind of what they're doing here, right? So you're really plugging the g of x into the f of x. So you're plugging this into the thing. So that's why that little arrow is going from the right to the left to kind of indicate how this is going. Okay, so let's try this. So let's say we have f, but instead of x, I put g of x, which in this case is x plus 7 equals, and then I say 4 times x plus 7. All right, we distribute 4 times x is 4x. 4 times 7 plus 28. And that is it. That's it. We got it. Hopefully that notation makes sense. Okay, now what about g composite of f, right? F of x. Well, in this case, what we're going to do is we're going to be plugging again backwards. So now instead of us plugging the g of x into the f, now we're plugging the f of x into the g. So now we have g of, well, we have g of f of x. Believe it or not, that's a g. Okay, well, what is f of x? Well, f of x is 4x. So wherever I see an x in the g function, now I'm going to be plugging in the 4x and adding 7, which just gives me 4x plus 7. So I end up with g of x equals 4x plus 7.